become sixth semester research methodology unit number 4. Data preparation and preliminary analysis. Data preparation is the process of cleaning and transforming raw data prior to processing and analysis. It is an important step prior to processing and often involves reformatting data, making corrections to data, and the combining of data sets to enrich data. Data preparation is often a lengthy undertaking for data professionals or business users, but it is essential as a prerequisite to put data in context in order to turn it into insights and eliminate bias resulting from poor data quality. For example, the data preparation process usually includes standardizing data formats, enriching source data, and or removing outliers. Benefits of data preparation. 76% of data scientists say that data preparation is the worst part of their job, but the efficient and accurate business decisions can only be made with clean data. Data preparation helps fix errors quickly. Data preparation helps catch errors before processing. After data has been removed from its original source, these errors become more difficult to understand and correct. Produce top quality data. Cleaning and reformatting data sets ensures that all the data used in analysis will be high quality, making better business decisions. Higher quality data that can be processed and analyzed more quickly and efficiently leads to more timely, efficient, and high quality business decisions. Additionally, as a data and data process moves to the cloud, data preparation moves with it for even greater benefits such as superior scalability. Cloud data preparation can grow at the place of the business enterprise. Don't have to worry about the underlying infrastructure or try to anticipate their evolutions. Future proof data cloud data preparation upgrades automatically so that new capabilities or problem fixes can be turned on as soon as they are released. This allows organization to stay ahead for the innovation curve without delaying or adding costs. Accelerated data usage and collaboration. Doing data preparation in the cloud means it is always on, does not require any technical installation, and lets teams collaboration on the work for faster results. Additionally, a good cloud native data preparation tool will offer other benefits like an intuitive and simple to use GUI, means graphical user interface, for easier and more efficient preparation. Data preparation steps. The specifics of the data preparation process vary by industry, organization, and need, but the framework remains largely on the same. Gathers data. The data preparation process begins with the finding the right data. It can come from existing data catalog or can be added ad hoc. Discover and access the data. After collecting the data, it is important to discover each data set. This step is getting to know the data and understanding what has to be done before the data becomes useful in the particular context. Cleanse and validate data. Cleaning up the data is traditionally the most time consuming part of the data preparation process, but it's crucial in removing faulty data and filling the gaps. Important tasks here includes removing extraneous data and outliers, filling the missing values, conforming data to a standardized pattern, masking private or sensitive data entries. Once data has been cleansed, It must be validated by testing for errors in the data preparation process. Up to this point, often times and errors in the system will become apparent during this step and will need to be resolved before moving forward. Transforming and enriched data. Transforming data is the process of updating the format or value entries in order to reach a well-defined outcome or to make the data more easily understood by a wider audience. Enriching data refers to adding the connecting data with other related information to provide deeper insights. Store data. Once prepared, the data can be stored or channelized into a third party application such as a business intelligence tool, clearing the way for processing and analyzing to take place. Preliminary steps in data quantitative data analysis. Preliminary steps in quantitative data analysis. After collecting and before analyzing survey data, we recommended closely examine the data sets to ensure the accuracy and representativeness of information and integrity of subsequent analysis. Data conditioning involves attending to detailed components of both an actual data sets and the particular analytic techniques chosen to examine the data. This often requires more time to attention to detail than either the data collection or the subsequent analytic procedure. Through data conditioning can be time intensive steps. Carefully executing these practices allow ones to responsibly proceed with the accurately analyzing and interpreting and reporting quantitative data. In addition, it offers a more fine graded fine grained picture to the study abroad the student sample, which can be quite informative and even before more focused on the statistical analysis are begin. Data accuracy. Data accuracy. The initial step, the data conditioning attends to the issue of the accuracy of data entry. This step requires an examination of how data have been entered or uploaded into the data file and a consideration of the issues that could yield inaccurate analysis. Comparing the actual obtained data to the final data file is an essential step. However, the size of the sample under study affect the methods by which this typically executed. Tabanchik and Fidel 2013 outlined several components to consider the ensuring data accuracy. For example, small data sets, careful proof reading, careful proofreading of all variable values is recommended. But for larger data sets, analyzing particular descriptive statistics and a graphical presentation of variable is typically more efficient in ensuring appropriate data value ranges. For example, possible minimum and maximum values. Analyzing descriptive statistics of the variable differs depending on the types of variable examined. Categorical and continuous variables. Categorical variables consist of the data that are grouped into the discrete categories, either nominal classification, divide of any other order or ordinal classification or that have a meaningful ranked order. For example, the location of a study abroad program, for example, Asia, Europe, South Africa, is a nominal variable, whereas asking participant to rate their responses to questions along with a Likert type rating scales. For example, 1 strongly disagree to 5 strongly agree, or 1 poor to 7 excellent. It is an example of ordinal values. Through the Likert type scales, responses are technically categorical variables. These responses are often treated as a continuous variable in data conditioning and later analysis. Continuous variable can earn numerical values within a defined range and have equal intervals between the data points. For example, a student age or number of months immersed in a host country. To check data accuracy for categorical variables, evaluators and researchers must examine the frequencies of responses in the each possible category. For example, utilizing the frequency functions in SPSS will display the tables that include the number of percentage of responses in each of variable categories, as well as the number of valid and missing values. After opening SPSS and loading your data file, follow these SPSS menu choices: analyze descriptive statistics and frequencies. In addition, various types of charts can also be generated through the same SPSS navigation to menu graphically displays the frequency, including bar charts, pie charts, and histograms. In looking at the frequency tables, we can find several questions that are helpful to ask. Are they values out of the range of the numbered categories? Example, there are three categories of the study abroad programs, typically arbitrarily numbered 1 through 3, but the frequency chart of the table indicates other number of categories beyond these three variables. Finding non-existent categories. Non-existent categories non-existent categories usually bring to light these types of data entries errors. What do the frequency suggest? How many responses are in each category? Which category contains the lowest and highest number of responses? What are the implications of low or high frequencies in the particular categories? To examine data accuracy for continuous variables, including Likert type scale, we must analyze other descriptive statistics beyond the frequencies. For instance, we often analyze the mean values, the averages, and dispersion in the range minimum and maximum values of the continuous variables in SPSS to answer the important questions about the accuracy of the data. Do all of the variables fall within the range of possible scores and not the point of data entry errors? Do the mean values values for the variable make sense based on what is the already known about the population of study? The dispersion of the variable is also important to examine, particularly if there are any out of range values below the minimum and beyond the maximum possible values. In addition, the standard deviation, the amount of variation of the mean. Standard deviation means the amount of variation. Variance means difference from the mean. It is also important to consider that that this indicates how closely values are dispersed around the samples mean. A low standard deviation value suggests that overall scores are generally clustered around the mean and little variation, making the likelihood of finding differences across the sample relatively small. Conversely, a high standard deviation values indicate that the sample's score are more widely dispersed across a wider range of scores, indicate a greater likelihood of differences in score within the sample. Finally, it is important to ensure that the missing data properly entered and coded in a data file. Data are missing from data files for several reasons, and these must be identified for the accurate analysis and reporting. Participants of, for instance, may choose not to answer the particular questions in a survey. Here, other may have inadvertently skipped the questions, skipped several questions and run out the time of completely survey, leaving some answers blank. Finally, the nature of the some sample survey may require the participants to legitimate skip and particular questions or blocks of the questions. In SPSS, missing values are indicates by the either an asterisk and a meanwhile star or absence of the any values. A more thorough discussion of missing data is found later. Participant response rates. Once the data are checked for accuracy, response rate must be carefully examined to understand the representativeness of the samples. For several reasons, it is often not possible to survey, interview, or otherwise investigate every individual and a population of interest. Comparing the sample participants and to larger overall population of the interest, examining how the representative and the sample is discussed, any significant distinction between the two is critical before finding in can be understood and applied more broadly. Furthermore, external validity, which consider the generalizability of one's findings of the extent to one's findings generalize the beyond the current sample to the overall population under the study is an important aim of quantitative inquiry. It is essential to know the report of a participant response rate by determining the total number of individuals invited to participate in study and those who actually participated. This is a simple proportion to calculate by dividing those who participated by the total invited through it important to take into account those who never received the initial invitation because of invalid email addresses or returned mail. Beyond understanding response rates, it is necessary to consider how response representatives a sample is relative to overall the population of interest. How many and what type of individual composition compose the overall population under the study, and how does this compare to your final stage. This sample representative is important demographic of the total population, including race, ethnicity, gender, age, and other salient characteristics are there over the under representative groups in the sample. What are the implications of these disparities? It is the data is not readily accessible on campus, institutionally, research and enrollment management areas can be typically provide the assistance in obtaining population data through beyond the scope of the characteristics chapter weighted techniques and can be applied in correct and non-response biases. Missing data. The issue of missing data is one of the most prevalent quandaries in quantitative research and assessment of efforts. In an extended discussion on the implications of the strategies of handling missing data, Tabanchik and Fidel 2013 started that it is essential to first determine the severity of the any missing data, particularly the pattern of missing data, the amount of data missing, and the reasons why the data may have missing. In quantitative research and missing data often categorized as MCAR. MCAR means missing completely at random. MAR, missing at random, which constitutes ignorable and non-responses, and MNAR, missing not at random, which constitutes non-ignorable and non-responsible. Little, Jorgensen and Long and Moore 2014 Randomly scattered missing values are less serious than the non-random missing values, as the later can affect the generalizability of the results. We can determine the random of the non-random missing data of the testing of pattern in the missing data. Tabanchik and Fidel 2013 recommended two ways to test this. First one can construct the new variable that represent cases with missing data and non-missing values for the independent variables. That, for example, a new variable could be created and coded as 0 missing and 1 is not missing, and then test of mean differences on the continuous outcomes measure between the groups and independent sample t-test follow the SPSS menus for this. Once the missing data pattern have been identified, there are a few different approaches and resulting implications in handling missing data that emphasize either excluding and substituting missing values. Excluding cases, particular participants with missing data from analyzing and reasonable options on the random pattern missing values. Very few participants have missing data, and the participants are missing data on the different variable, and appears that the missing cases represent and random subsample of the aggregate sample. Tabanchik and Fidel, that by default it is provided as the previous points. Over 10% most cases of the compromising data can be result. And this is the details. And detecting outliers, extreme values. Occasionally, outliers and extreme values and expected values surface the data and must be addressed, especially with small sample sizes. Participants can randomly respond to questions or represent genuinely rare cases. Often helpful, the examining and attached the particular participant to see the fuller pictures available and unvariable outliers. This is the recommendations of Tabanchik and Fidel about to missing data. Next, looking correlational among variables. Data conditioning also involves the examining of the degree to which continuous variables, including Likert scale and correlated and related to one another. Note that the correlation not a viable using categorical data and numerical values variable not meaningful in the data. It can be ranges from the correlation is ranges from -1 to +1 0. And next one, graphical representation of data, compulsory question. Graphical representation of data, bar diagram or histogram. Data can be represented in form of organized information combined in tables and even graphically represented. Imagine seeing a set of data in written form or tabular form versus a graph and gives you the same information. Is not a simplifier and quicker to comprehend the data if we can visually see it. It is for the purpose that the data can be organized graphically for the interpretation of a single glance of statistics. The two forms of graphical interpretation that we shall cover the lesson of bar diagram and histogram. Bar diagram, also known as column graph or column graph or a bar graph or a bar diagram, a pictorial representation of data. It is shown in the form of rectangular spaced out with equal spaces between them, and having equal width. The equal width and equal space criteria are important characteristics of the bar graph. Note the height and length of each bar correspondence of the frequency of the particular observation. You can draw a bar graph both vertically and horizontally depending upon the whether you take the frequency along with the vertical and horizontal axis representatively. Let us take an example of understand how the bar graph is drawn. Sports and number of students. Basketball, volleyball, football. 15, 25, 10. Total altogether 50. The above data depicts the number of students of the class engaged in one only the three sports given. Note the number of students in actual frequency. So if it is take the frequency of the represented and y-axis and sports on the x-axis, take each unit of the y-axis to be equal 5 students, we will get the graph at the resemble one below like this. The blue rectangulars here are called bars. Not all the bars have equal and width and are equally spaced. Mentioned above, the simple bar diagram. Next, pie diagram. A pie chart or pie graph is a circular statistical graphical chart which is divided into slices in order to explain or illustrate numerical proportions. In pie chart, angle central angle area and the arc length of the each slice is proportion to the quantitative percentage if represents total percentage should be 100 and total of the arc measures should be 360 degrees. Following illustration of a pie graph depicts the cost of construction of a house. For example, cost of construction of house: timber 10%, supervision 15%, steel 15%, bricks 15%, cement 20%, and labor 25%. From the above graph, one can compare the sum spent on cement, steel, and so on. One can also compute the actual sum spent on each individual expenses. Consider an example where we want to know how much more is the labor cost when compared to the cost of steel. Amount spent on labor like this. Spent on steel excess. Let us like this. This is the mathematical part. No need. This is only for information. This is the fourth unit of research methodology. The syllabus framed by Shatavana University. Thank you very much.